This is a tutorial video for Unit 3 of AQA GCSE Chemistry, the quantitative chemistry unit. In this video, we're looking at the volumes taken up by gases, including what a decimetre cubed is and how much volume 1 mole of gas takes up. Part 2 in this series will cover the volume of gas produced in a particular chemical reaction. If you'd like to follow along, there's a link to the worksheet in the description below. By the end of this video, you should be able to recall that 1 mole of gas takes up 24 decimetres cubed of volume under standard conditions, and know what those standard conditions are. You should be able to calculate the volumes taken up by known moles of gas, and calculate the moles of gas in a known volume. Finally, you should be able to use the mass equals Mr. Mole equation together with this information to calculate the volumes taken up by known masses of gas. It's possible, and dare I say it even likely, that you won't have encountered the units that chemists use for measuring volumes of gases before. While it's not hugely important for today that you understand where they fit in the scale of other units you are familiar with, you are going to need to know eventually, so we might as well look at it now. This is a decimetre. A decimetre is 1/10 of a metre, because dec or dec always means 10, like a decade or to decimate. So 1 decimetre is 1/10 of a metre, 0.1 metres, and it's also equivalent to 10 centimetres. Now, if you imagine a cube, and each side of that cube is 1 decimetre long, then the volume of that cube is of course found by multiplying those lengths together to get 1 decimetre cubed. And this is the unit of volume that we're going to use for measuring gases, and later on for measuring solutions too. Now, if we turned those into centimetres and said that 1 decimetre is the same thing as 10 centimetres, then when I multiplied all of those together, I get a volume of 1,000 centimetres cubed. So we can say that there are 1,000 centimetres cubed inside a decimetre cubed, and there's also 1,000 decimetres cubed inside a metre cubed. The important thing to note here is that a decimetre cubed or a centimetre cubed is a unit of volume. The cubed is part of the unit. It doesn't affect any of the numbers that come before it. So at no point in any of these calculations are you going to be needing to cube anything. There's really only one fact that you need to learn for this part of the specification, and the rest of it is just practice calculations and rearranging formulae. So the fact is this: 1 mole of gas takes up 24 decimetres cubed under standard conditions. What that means is, it doesn't matter what the gas is. 1 mole of hydrogen, 1 mole of nitrogen, 1 mole of gold that we've heated up so hot that it's turned into a gas, 1 mole is going to take up the same amount of volume. When we say standard conditions, we basically mean, what's it like in this room right now? So standard conditions for GCSE chemistry is defined as 1 atmospheric pressure and 20 degrees C. So we're going to start with some really straightforward calculations. If 1 mole of gas takes up 24 decimetres cubed of space, then how much volume does each of these take up? 2 moles of gas will take up 48 decimetres cubed of volume, 5 moles of gas will take up 120 decimetres cubed of volume, 12 moles of gas will take up 288 decimetres cubed of volume, and of course we can always have less than 1 mole, in the same way that we can have 500,000. So 0.4 moles of gas will take up 9.6 decimetres cubed, and 0.25 moles of gas will take up 6 decimetres cubed. Next, you need to be able to work in the opposite direction in order to work out how many moles of gas have you got if you know the volume. So at the moment in my equation, moles is multiplied by 24 decimetres cubed, and I need to get moles on its own, so I need to get rid of that 24 decimetres cubed. Right now it's multiplying, so to get rid of it I do the inverse operation, I divide, and whatever I do to my right side of the equation I do to the left. So that ends up moving over to the left, and I now have volume divided by 24 will give me moles. So for instance, if I want to know how many moles of gas there are in 60 decimetres cubed, I do 60 divided by 24, and I get an answer of 2.5 moles. Pause the video and have a go at the rest of these. So 18 decimetres cubed divided by 24 gives me 0.75 moles. 4.8 decimetres cubed is 0.2 moles, 17.4 decimetres cubed is 0.725 moles, and 96 decimetres cubed is 4 moles. I hate to say it, but it's really unlikely that you're going to get something that straightforward. It's much more likely that you'll get a question like these ones. So in these questions, you're given the mass of a particular compound and asked what volume it will take up. So your first step is going to need to be to work out what the relative formula mass is. So here I start with carbon dioxide, and the relative formula mass can be found by adding together 12 for the relative atomic mass of carbon, and then 2 lots of 16 for the relative atomic mass of oxygen, which gives me a total of 44 grams per mole. I can use that information to work out how many moles 440 grams is. 440 divided by 44 tells me there are 10 moles of gas. And now, since I know 1 mole takes up 24 decimetres cubed, I can work out that 10 moles will take up 240. Pause the video and have a go at the other questions yourself. Hydrogen chloride has a relative formula mass of 36.5, which means that 73 grams is 2 moles, and therefore it will take up 48 decimetres cubed. Nitrogen dioxide has a relative formula mass of 46, which means that 165.6 grams is 3.6 moles, which will take up 86.4 decimetres cubed. Methane has a relative formula mass of 16, which means that 80 grams is 5 moles, and that will take up 120 decimetres cubed. And silver has a relative atomic mass of 108. So if it was turned into a gas, that would be 0.1 moles, and it would take up 2.4 decimetres cubed. Thank you very much for watching, and I hope you're enjoying learning some quantitative chemistry with us. If you are finding it useful, then don't forget to let me know in the comments below, and like and subscribe for more GCSE chemistry videos coming soon.